I am a huge fan of real-time analytic databases, warehouses, query engines. For background, I worked at a company before starting Rill that actually created one of these databases called Apache Druid. And it's fair to say I've watched from the sidelines while all three of these gentlemen have been building businesses with some amazing technology that I can honestly say are superior versions of the real-time analytics database that we created ourselves. So hopefully we inspired some of those architecture choices or inspired some false lessons about what not to do with our own work. So to introduce the folks I've got here, I'm going to start on my right. By the way, do we have some music going? Can we cut that? Okay, great. I mean, I love a little samba, but maybe before we get into the core here, I'm delighted to have Yury, the president and co-founder of ClickHouse, here with me. Yury has I can say he's done time at some of the largest and most successful companies here in Silicon Valley. Most recently, Google, but also before that, Yahoo, where he overlapped with Kishore. And next, Kishore. We've got Kishore, who is the founder and CEO of StarTree, the commercializers of Apache Pinot. Kishore worked at LinkedIn, where he actually invented Apache Pinot, and then went on to start StarTree, which we'll talk more about in a bit. And finally, certainly last and not least, the only non-Yahoo of the three who's actually, believe it or not, Jordan, we found out we were classmates many years ago. We graduated the same year. We probably met at some point, but Jordan is the co-founder and CEO of MotherDuck, the commercializers of a DuckDB cloud offering. And before that, Jordan was running product at a company called Single Store. Before that, very involved at Google, again, overlapping with Yury, who's been everywhere, working on BigQuery. So we're going to get into it. The first question I've got for this distinguished panel, databases. I mean, the joke is it takes, every database company is an overnight success after 7 years. I'm going to start with Jordan, which is, maybe you're the most recent. We're going to go back. Jordan, just if you could tell us what was going through your mind when you thought it was a good idea to found yet another database company? And I'll ask it, I know, like, to add a layer to that is like, what were the gaps in the market that you observed, and what gave you the courage and confidence to go out and ask folks like Martine and some of your initial investors to write big checks to create and found yet another database company?
So one of the things that I had been noticing was, I'd worked at BigQuery for 10 years, and we had some of the largest customers in the world. We had Equifax, Home Depot, Walmart, and I dug into how people were actually using their data, and the vast majority of customers using BigQuery didn't have big data. The ones that did have big data, they only used like small slices of data at a time. And so I kind of filed that away. I worked at Single Store for a couple of years, and I just sort of noticed that people were asking us for smaller instance sizes, and then we spent all this time building this distributed infrastructure, and some of our most successful customers were actually ones that were just running on a giant box. Like I think Sony was one of the largest customers, and they were running like these massive, massive boxes, and they never had any problems. It was like, wow, that's, that there's something to like, they never have any problems, it just works. And, kind of what the shape of modern hardware is different than when we started, building BigQuery. And then I saw this database, this open source database start showing up in some benchmarking reports that was like giving us a run for the money. And like, MemSQL, Single Store, like our whole thing was like speed and like, we're going to do whatever it takes to be fast. And then like this sort of random couple of like graduate students, academics in the Netherlands were like, we're getting pretty close out of nowhere. And I'm like, somebody should really take that and build a serverless, cloud version of it. And I'm like, hey, I've built 2 SaaS databases, and maybe that should be me. And kind of I thought about it a little more, and I sort of tripped and fell, and Martine, offered me a term sheet, and And I realize that not every founder's journey is, fundraising journey is that way, but I sort of stumbled into starting a database company.
I have a follow-up question, but I'm gonna go down and ask the same question. Oh, great, you guys are sharing. So, Kishore, same question. What was the gap in the market? When you started StarTree, there were Apache Druid was out there. ClickHouse, I think, did exist and was open source at that point. What motivated you to have the courage and the confidence to go and actually start StarTree and try to build yet another database business?
Yeah, before getting to that, I do want to answer your previous question on why did we build Pinot in the first place.
Sure.
Right? I think, to be honest, I actually didn't want to build another database. I had built one before this, which was like MongoDB called Espresso. It's very hard, as you said, right? And I think you mentioned it takes 7 years. I think it takes 7 years to realize that it's hard. So I think that's when you really get into the details of what's a database. I think for us, it was kind of completely opposite. That's kind of what Jordan was actually talking about. For us at LinkedIn, we were actually going in the other direction of scale, right? I think most of you know like who viewed my profile on LinkedIn, right? That's kind of one of the things that actually drove us to build this, which was there are 5,000 people looking at it at any given second, right? And that was not really something that people thought about analytics and this kind of a workload on top of that. So it's for us, we were seeing this kind of OLAP functionality being needed at OLTP scale. Right? So that's kind of what got us excited as well. That hey, this is two hard things. On one side, you have like tons and tons of transactions coming in at the same time, you want to provide rich analytical functions. And the second part was also who we were serving. I think the who was actually a very important part for us. It was not internal members of LinkedIn or within the company. This is really the users of LinkedIn. So when you actually start providing analytics. You
call that user-facing analytics.
User-facing analytics. So that's kind of the term that we coined, which is really very different when you actually get into the weeds of it. Is your users are not going to wait for a page to load for seconds, right? I mean, it's okay in the data warehouse internal use cases because you don't have the option. But when you serve something to your end users, you got to be in milliseconds. And for us, we were actually having P99 latencies and alerts on that. So very different requirements. And that's kind of when we said, like, hey, most of the existing databases were not catering to that workload characteristics. And we said, like, oh, we need to approach it from first principles, go back to see, like, hey, what can we do to reduce the work done per query? And I think that was our key thing versus just doing it faster.
Yury, the same question, which is, you could have just been a comfortable guy. You were a VP at Google. It's a great place to, just collect. Not to say it's an easy place, but you decided, or someone convinced you to say, Yury, do you want to just be a, important big guy at Google, or do you want to get into the weeds of a brand new startup and start from zero and create a database business? What convinced you that ClickHouse should be another database company?
Yeah, so I was at Google when I first heard about ClickHouse, actually working together with the best dressed man in the room, with Jordan.
In yellow, Jordan, your colleague Jordan.
With my colleague Jordan, we're having a great time in Google Cloud. But yeah, the first time I heard about ClickHouse, by the way, disclaimer, I did not create ClickHouse originally. It was first created back in 2009 by Alexey Milovidov, one of my co-founders, and open sourced in 2016. And I first heard about it actually from my little brother, who was working at Uber at that time, and they were having issues scaling their analytics platform. They were using Elastic and Splunk and some other things, and they did a bake-off. And they tried all sorts of different databases and technologies to see which one would work best. And ClickHouse was by far, in a way, the best system. They just outperformed everything else, head and shoulders above. And I remember him calling me and was like, Yury, what do you know about ClickHouse? I'm like, I don't know anything about ClickHouse. What is it? It's like, yeah, check it out. It's really, really good. And I remember I downloaded it on my laptop. I installed it. And I started running queries, and I thought things were broken because it was so fast. It just comes back right away. It's like, this can't be right. So I filled up my entire laptop hard drive with data, and I kept running queries, and it still kept coming back immediately in real time. And that's like, wow, this is really amazing. And then over the years, I kept hearing more and more, companies like Uber and eBay and Microsoft and others just kept adopting it and talking about it. And then in 21, when an opportunity came up to take the IP and bring over the team of original ClickHouse developers and build a business around it and create a cloud service around it, I just jumped in.
It was a no-brainer.
It was a no-brainer. Okay. Like when you start with really, really great technology, everything else is easy.
Okay, so it was more than 7 years that that ClickHouse had been baking and then kind of...
It takes, I would say, more like 10 plus years to really harden database technology. And again, you can't take risks. This is data, the most valuable thing that any of us have, well, other than our children, of course. So
hey, if our children are listening, you're the most valuable thing out there, so right. They know.
And so, yeah, you really, really want something that's battle-hardened and can be trusted.
So you talk about the opportunity to create a cloud service, and then in terms of like lineage and origin story, it's fair to, Jordan, also, I think I'd love to ask you this question, which is, tell us a little bit, similarly, you are not the creator of DuckDB, certainly the creator of the leading commercial business that is using DuckDB. I think the key question that a lot of folks have is there's an open source product, and then there's this cloud offering. And love to hear from you, and I'm going to maybe add layer another question on, which is that I've heard about this small data movement, and the thing that I think about when I hear small data is if someone pitched me on a banking idea for, we looked at all of our customers at banks, and we found that most customers don't have a lot of money. So I'm going to build a bank for small balances. I'm going to build a bank for people who have not a lot of money. I don't know that I would, as an investor, get excited about a bank for small balances. And when they get big enough, they'll go to JP Morgan and lose their business. But that's the side. Question is, what is the difference between the DuckDB architecture that people love running locally on small data, and certainly that inspired you to say, wow, this is something to build, and what MotherDuck is doing in the cloud?
So first of all, I think it would be an awesome idea to build a bank for small balances, because the vast majority of people have small balances, and the vast majority of banks, all they really care about is their customers that have a shit ton of money. And so, I think you could have a great, user-focused banking experience that could do really well. And I think actually that ties into what we want to do at MotherDuck, is because if yes, there are use cases for lots of data, and yes, some people have lots of data, but I built software systems for 20 some years, and as you're designing a system, if you have a 99% workload and a 1% workload, if you design your system for the 1% workload, then you're going to totally skew how that thing works. So you want to design for the common workload and make sure the other thing works. And so with DuckDB, being designed for single node scale up, it works super well in that mode. And with modern database techniques where you page data out when it's not being used, you can handle the giant workloads, but then you can also give an amazing experience on the smaller use cases. So you also asked about how do you deal with the the open source versus the SaaS version, and so originally I went to Hannes and Mark, and who were the creators of DuckDB, and I said hey, what you guys have built is amazing. Will you give me a job? And I'd love to sort of work with you and build a SaaS service. You're probably building a SaaS service. And they said, we don't want to build a SaaS service. We just want to focus on building this amazing database, but we'll partner with you. And so I'm like, that sounds interesting. And so I ended up talking to some VCs actually later in the same day, who then turned around and wanted to invest. But I think the other key thing was like we didn't want to just say like, hey, you guys built an amazing database. We're going to go kind of take that IP and try to make a bunch of money out of it. So we gave them a co-founder share of the company. As we did it, they gave us an exclusive. They weren't going to work with anybody else that was competing with us. And then we also funded some of the development of DuckDB, which I think is actually a really, really nice and a stable division of labor between open source and closed source, because we are unapologetically a company that wants to make money, and our investors would like to hear that, because they've invested a decent amount of money in us. But DuckDB, DuckDB Labs, they get to focus on the idealist sort of building an amazing database, and like they get to sort of they could be pure. They get to not worry, like there's no pressure on them. We can't put pressure on them to change the license. The license, it's owned, the IP is owned by the DuckDB Foundation. If we told them we wanted them to change the license, they would, tell us, something.
Get lost.
Something very
something in Dutch that you don't understand.
Or some, or even in German even that would sound, even filthier. And so like, I think it's great, and if things work out for us, then it also works out for them, and then they get to focus on the thing that they love doing, and I'm hoping that this becomes if it works out for us, it'll be a model that other people can follow in the open source world. If it doesn't work out, it'll be a cautionary tale.
But they'll be learning either way.
Yeah, exactly.
So, Kishore, one of the things that people often ask when it comes to the way that open source companies monetize when they build a commercial cloud offering is the licensing model or the consumption model. What I've heard when I've talked to some of your customers who are using StarTree to leverage the power of Apache Pinot is that I'd heard that you had a pretty unique licensing model that was different than maybe what was being offered from others. Tell us a little bit about what that model is. And I guess to frame it, I often think of two models. One is actually two axes. One is a consumption model, which is just a snowflake model. They have those magical snowflake credits that you have no idea what they mean, but you're consuming them and they cost a lot of money. And then you've got a licensing model, which is obviously you pay, all you can eat. Maybe that's seat-based. Sometimes it's company-wide. What model has StarTree found to be most appealing to your customer base, and why?
Yeah, I mean, obviously, as from a company's point of view, everyone loves Snowflake model because you kind of take the credit.
The investors love it?
I mean, the company, everyone loves it, but the customers don't really like it, right? I think.
You're right. Everybody but the customers. But hey, who cares about the customers, right?
So I think what happened when we started, we actually tried to talk to the customers and see like what is the thing that they actually love, right? And I think at that point, most of them were burnt by the Snowflake model because they take it and then everything gets used up very quickly. And I think there was also another part of it, which was the incentives are actually not lined up. And if you kind of put yourself in the Snowflake's position, right? I mean, I don't want to make my database faster because if I make my database faster, my customers will be using lesser credit, so it will be
drop and replace. Sounds great. Maybe DBT is a great ETL framework. We just keep dropping and replacing these tables.
Yes. So in a way, inefficiency is slightly better there, right? So that's where our model was actually slightly different because we wanted our customers to run as many queries as possible because that's where really the true value is. And we wanted to say, hey, you should be running thousands and hundreds of thousands of queries per second. And that's where we went into the other model is like, here is what we can actually prove a single core can actually do, right? Mm-hmm. So that's where we went to the core model and say like, as long as you have this core, you can actually run as many queries as possible and continue to ingest as many events as needed as well. So we didn't want them to be thinking about, I have to pay per query, per event. It's just a very complicated model for them to reason about. And we wanted to prove that, hey, with a small number of cores, you can actually do a ton of queries. And for us, that was really the value that we would see from our customer side is how many queries are you running on a per second basis. And I mean, we have the data. I mean, Snowflake took probably like 10 years to get like 1 billion queries per day. We were there in 3 years across our customers, and we are way 10x more compared to that.
1 billion queries a day, meaning 1 billion queries across their customer base?
Yes.
Okay,
Yeah.
interesting.
So that's like, that's kind of what we really want to show the
Right.
world, that you can. I mean, if you just look at LinkedIn today is running at 600 million queries per day, just LinkedIn.
So that means Snowflake's making a lot of money per query.
Exactly. I think that's the key idea, right? And if you look at it, our goal is to really reduce that cost per query model. And
Right.
and this is again for going back to what Kafka did at LinkedIn as well, and that's kind of why people are logging a lot of events today, is because the cost per logging an event is actually drastically reduced
Right.
compared to the prior models. So that's what we want people to be running a lot of queries using the data.
Without worrying about getting charged, right,
Exactly.
per query. Okay, so Yury, I know that the ClickHouse blog, I guess it was maybe 18 months ago, maybe a year ago, you had a very expansive discussion, exposition of the architecture of ClickHouse Cloud. You know, I would say as an observer, one of the disadvantages sometimes of having a great open source product as a core technology is that it's so great that people are like, well, gosh, we just like, ClickHouse is amazing. They had that same experience you had. It's so fast on my laptop. Maybe give us a sense of, I guess, two questions. One is, what is the architecture of ClickHouse Cloud? And in particular, why did you choose an architecture to drive what differentiation? What differentiates ClickHouse Cloud from running ClickHouse on a really beefy, huge machine on Amazon or Google? And what's the architecture of the cloud offering that allows for that differentiation?
Sure, it's a great question. So, and I guess if you take a step back and you just look at the idea of open source being free software, why on earth would you pay a company for something that you can get for free?
Right.
Right, exactly. So, great question. And there are many, many reasons why you would want to do that. So when people deploy ClickHouse open source, self-managed deployment, typically it's using shared nothing architecture where the data sits directly on the nodes. It's much simpler this way, and it can be pretty fast, but the downside is it's very rigid. Because there's a lot of data and metadata to maintain and manage, it's very hard to do upgrades. It's very difficult to scale the cluster up and down, replace the nodes if something fails. So it's a very, very rigid structure. You have to over-provision for your peak loads, and you have to pay for it 24/7. In the cloud, when we first created the company and decided to build a cloud product, we chose a very different architecture under the hood. Again, queries, functionally, it's the same thing. The same queries you run in open source, you can run in our cloud product. But under the hood, it's a completely different architecture. So we moved away from shared nothing to compute and storage separation, where the data sits in object storage like S3 or GCS. And the compute nodes are completely stateless. We're not keeping any data or even metadata on those nodes. And of course, we do caching and prefetching and all of that stuff to make it fast, but it's not required that the data sits there. And as a result, it allows you to do scaling up and down instantaneously. You can do idling. You can even do things like compute separation, where you have different compute clusters for different use cases, like separating reads and writes, or different organizations who don't want to step on each other's toes or have different budgets. You can do all of that with this architecture. And because it's serverless, it scales up and down, you only pay for what you use, and it actually ends up being cheaper. So not only is it more reliable because it can scale up to whatever your peaks are, and it scales with the elasticity of the underlying cloud provider, but it is also cheaper for you. And on top of it, our cloud product, we've added a whole bunch of security features like cloud-native identity and access management, RBAC, bring your own key. We can do FIPS compliant 140-2 builds. There's a whole slew of certifications, ISO, SOC 2 Type 2, PCI, HIPAA, working at FedRAMP, and so forth. And of course, it's a fully managed product, right? It's got a great console. We do backups, restores. There's a nice SQL editor with an AI agent that can, with a semantic interface, you just tell it what to do, and it does a great job building queries. So it's a much, much nicer experience. It's like being in a self-driving car. It just takes you wherever you need to go. You don't need to worry about anything.
That's, it's like the enthusiasm is fantastic. It's like Elon telling us about the full self-driving cars that are soon going to be running our entire taxi fleets.
That's right. I'm 100% objective, no bias at all.
But I will say on the security features, we do know that DeepSeek probably could have used some of those security features because they had a leak on their ClickHouse cluster, what was the result of that leak? They just gave away all the prompts or something? What was the...
It wasn't nothing as far as I can tell.
It's complimentary that they were using ClickHouse, but they were not using ClickHouse Cloud Security.
It's interesting. Well, they were not using ClickHouse Cloud at all. They were using open source, and they actually went out of their way to open up some of those ports that by default are not open to the internet. So they shot themselves in the foot. But yeah, had they used ClickHouse Cloud, they would have been much, much better off.
Well, we'll see if they come to the, you get an inbound marketing request for a demo from those guys in the coming days. One of the things you talked about with the architecture of ClickHouse Cloud is that separation of compute and storage. Certainly that was the innovation that Snowflake touted for, why they were able to kind of take the traditional warehouse market in the way that they did. The topic that's on a lot of our minds, or the technology that we hear so much about these days, is Lakehouse. Here we are at the chalet. I wish it were a little nicer out, but we are in an actual lake house. So I would be remiss if we didn't talk about lake houses. Amazing marketing term, whoever came up with it. Someone at Databricks deserves a promotion for that.
ClickHouse had nothing to do with it, although it fits perfect.
That's right.
ClickHouse, Lakehouse.
Lakehouse. Houses are good. Well, we have One House as another database company out there. But Jordan, I've heard from folks in the DuckDB world that this is the year of the Lakehouse. Tell us a little bit about Iceberg. This is the technology that Databricks paid $2 billion for. Tabular, the guys behind the Apache Iceberg project. How is MotherDuck embracing, complementing, working with this, what many of us feel is the future substrate of all data?
So first of all, I'm perhaps a little bit of a Lakehouse skeptic. I think that there are, I built the storage system for BigQuery, and so I kind of have been deeply involved in data warehouse storage.
You know too much.
For a long time, and there's a lot of benefit to being able to couple the query engine and the storage layer, and you probably lose a factor of at least 3 in order to do that. Maybe that's fast enough. Maybe that's fine. I also think that there's a bunch of things that you give up in security realm, in the metadata management and fast updates and transactionality to do Iceberg. And I think there's a lot of excitement around Iceberg, and a lot of people want to move to Iceberg. But I think people are also moving relatively slowly, and I think partly that's because they're butting their head against some of these problems. So that's sort of my general philosophy, background. On the other hand, there is this huge groundswell of excitement and interest about Iceberg, and for us, it seems like it's pretty ideal, because if your data is in Snowflake, and we want to acquire you as a customer, you want to try out MotherDuck, we have to convince you to migrate your data from Snowflake to MotherDuck. If your data is in Iceberg and you want to use MotherDuck, well, we have the same access to that data as Snowflake does, and if we can do things a lot less expensively, and we can do things with a lot lower latency, that's actually quite a good thing for us. And I think there's also some things that were hinted about in Hannes's talk. I think he showed a logo and he didn't even say the name, so I'm not even going to say the name. But it is coming out.
Can you describe the shape of the logo for us so we can?
There's a duck and there's a lake, and you can kind of imagine them coupled somehow. But But so that is coming, and I think there are some really interesting architectural things that can come out of that. I also want to take umbrage to the snowflake driving the separation of storage and compute, because BigQuery did that like 3 years
Sure.
earlier, and we just sort of didn't pound our chests nearly as much.
Right. Well, it's Google. There's a lot of things that Google could market better than
Well,
it.
yes, true.
Kishore, same question for you. And maybe to drill in on what Jordan said, and I'll say, in my experience, we all know that we saw, those of us who saw Hamilton's talk today know that one of the beautiful things about DuckDB is that as a developer, you're running so close to the metal, right? You have your data local, and those iteration loops are so joyful, and local development remains something that exists. And yet, for scale, of course, we have to go to the cloud, and for even more scale, we have to embrace things like object storage. If you talk about efficiency and performance as the highlights of Apache Pinot, how are you thinking about cloud object storage and the separation of compute and storage and your cloud architecture?
Yeah, for us, we have been thinking about this for quite some time. I think we built the architecture so that the storage and the compute can actually be decoupled. But we have been, similar to what Jordan, I really don't know how to serve the use cases that we are serving today with Iceberg. I understand it's so popular and a lot of people are using it. There is no way you can actually get the latency that you can get with the local storage. It's done for scanning purposes. It's really good. You add the additional overhead. But when you're looking at millisecond latency, a call to a remote cluster is like 100 to 200 milliseconds. So there is no way you're getting that kind of a latency with remote. So instead, what we are thinking along is to actually, we do have the ability to separate the storage and compute at StarTree, but we try to keep our Pinot format in that instead of the Iceberg format. So we are adding the support for Iceberg, but that's more for when you're okay to trade off some of the things, right? And where you don't really need that latency, you don't need that concurrency, you don't even need that freshness. I think that's the case where you can actually go for that. But really, the format that we have built is completely optimized for random access and not sequential access. And those are all the things as you get deeper and deeper, is just day and night difference. And it's very hard for us to provide that kind of latency guarantees to the user.
Sadly, the best storage format doesn't always win in the history of technology, but can totally understand how the limitations of Iceberg. Yury, what is ClickHouse doing? You've talked broadly about compute storage separation, but Iceberg specifically, how is ClickHouse thinking about support for this technology?
Yeah, well, first of all, disclaimer, so I'm partial to Iceberg as well. Toby and I, we worked at Netflix together, and I was involved also with the origins of that, so I think it's great technology. When it comes to ClickHouse and data lakes, so kind of like your question, why data lakes versus vertically integrated data warehouses? And a few years back, the answer would have been data warehouses are faster, but data lakes are cheaper because it's cheaper. You just throw it in an S3 or some object storage, and you're more flexible in terms of ingesting all sorts of data, structured data, semi-structured data, whatever have you. And there's also more versatility in terms of which query engines you can run on top of it. So if you want best performance, you use data warehouses. If you want lower costs or more flexibility and versatility, you use data lakes. Well, let's see where we are today. And again, things have been changing. Snowflake has integrated Iceberg as a first class, and Databricks has more data warehousing capability. But when you look at ClickHouse today, right? Well, obviously, it is faster to run queries in ClickHouse native storage. And again, like a decade and a half of investment in the merge tree architecture, and and skip indices and everything else that makes ClickHouse really fast. It is impossible to reproduce it today on top of Iceberg. So you do have much faster queries that way. However, because ClickHouse uses object storage as well, And actually, the compression, the native ClickHouse compression, is actually better than Parquet, which is columnar format that's often used in data lakes by about 20 to 40%. It's also cheaper, and we don't mark up our store. I mean, you pretty much pay, there is $20 per terabyte per month. And so it's faster, it's cheaper, and you also have the flexibility with semi-structured data, with JSONs. Now they're a first-class citizen with ClickHouse, and we put a lot of work. And actually, if you want to read something really cool about, like just an architectural trick, the variant data type of transposing JSON objects, the tuples, into the columnar storage, which is very non-trivial, and how it was implemented, it's amazing. Once we implemented it, gave us like 3 orders of magnitude performance improvement. There's actually a benchmark called JSON Bench. You can Google it.
That you guys created.
Well, it's
No, right. But it's true that ClickBench is a very widely adopted benchmark that Click has
ClickBench
created.
and JSON Bench as well, yeah.
So in fairness, you have created benchmarks that are widely used.
That's right. Yeah, like you can compare the performance on JSON Bench of various systems, and ClickHouse, thankfully, is far ahead. So it's cheaper, it's faster, you have the flexibility with semi-structured data, but if you're an enterprise with a long history of using, I don't know, Spark, Trino, Dremio, whatever other query engines, and you don't want to migrate everything, yeah, you can run ClickHouse side by side on top of Iceberg. We support all of the cool features, schema evolution, time travel. Right now we support Iceberg v2. We're working in v3. Eventually you'll be able to write into it. So yeah, it is a first-class citizen, and we're definitely betting very heavily on Iceberg. Is it the same performance? No, at least not yet. But yeah, whatever works best for you.
Right. Okay, last set of questions, and then we're going to turn over some Q&A. I am looking to be thoughtful. I promised for folks who said that their children were the most important thing to them that we would get them home to see their children tonight, so before bed. The question is, the topic, of course, we'd be remiss not to mention is AI. And I'm going to frame the question of 2 parts, which is for each of you, what are the actual real-world use cases for AI in your current companies? What do you see real, palpable value? And then, secondly, what's your prediction for how this fourth technology revolution we're living amidst might impact or change the course of your business? So first the real, and then the fantasy prediction.
So Kishore, I noticed you gave up the microphone pretty quick.
No, we're all going right, exactly. We're forcing you to go first. We're going to go left to right, or right to left.
I'm fine to go first. But obviously AI is changing things very quickly. It's changing things super quickly for developers. Everybody's using Cursor. Everybody's using like MCP servers. And it seems like every week there's something different. AI is changing, or it seems to be changing the data world a lot more slowly than it is the world of software. And if anybody got a chance to see Hamilton's talk today about instant SQL, he kind of talks a lot about, hey, there's no real SQL, there's no debugger for SQL, and kind of the kinds of tools that data analysts and data scientists have been using kind of are trapped in the 70s for a lot of use cases. That said, there are certainly ways that we can apply AI to make the process of data analytics better. A lot of people talk about how text to SQL is fundamentally broken without a metrics layer, and that's why a lot of people are excited about metrics layers.
It's a really great point you made there. Metrics layers are great.
Yeah, so one of the things that we want to do. Actually, we've seen people using text to SQL in constrained schema situations, people building embedded applications, analytical applications. They have a single schema for all of their customers, and they can have very, very clean semantics on that schema, and you can get actually really good text to SQL performance. But if you want to solve the sort of the general nasty, messy data warehouse problem where you have like, I think you were talking earlier about like, latest table underscore v3 final like, and that has the same schema as 17 other tables. Like it's very, very hard for AI to know, which table to pick, let alone like how you compute ARR, let alone like, whether you have your fiscal year starts on February. I do think that there's going to be, a lot of opportunities for tools to help with this, a lot of opportunities to sort of just help automate certain things and just sort of make the process of writing queries a lot more delightful, like automatically filling in defaults, automatically, really, really good autocomplete. I think there's also some things with like better context windows and probably the ability to actually generate better SQL and better metrics layers. But I think there's also a lot of opportunity in that space. There's a lot. I think anytime things aren't clear, it's like. It's an opportunity for somebody to come in and do things better. And I've certainly talked to a bunch of founders that are working on interesting things in the space. But I don't think it's certainly an area where I don't think anybody has like conclusively solved the data problems with AI.
I'm going to prompt Kishore because we talked about this in our Data on the Rocks interview.
Since most of our users are user-facing applications, so that means they're building applications for their end users. And there, people actually do click this, then go do this, then click this. I think a lot of these tools are actually becoming conversational apps. So it's actually lowering the bar of who can actually access this, because even if they have a very nice dashboard, it's still you have to learn something. Or like, hey, if I need to answer this question, I need to go in so many different places. So it's actually pretty interesting. Some of our customers have just thrown away their dashboards, just build a conversational app on top of it. And I think to Jordan's point, it's actually possible in our case because it's restricted. It's very well defined in terms of the schema and the metadata that you provide. You don't have final tables. So it makes it a little bit more constrained in terms of the problem. So that's one thing that's actually very interesting.
I think it's a point for all three of the engines that the database technologies you've built. There's the speed, and when we talk about conversational AI agents, a core tenet of intelligence is that if I ask you a question, we don't have to wait 60 seconds for an answer. So all the potential for using agents requires having a fast back end to be able to serve that. Yury, when you and I were talking before, and this will be you'll get the final word on AI, and then we'll open it up for questions. You showed me this thing that I was amazed by, which is it llm.clickhouse.com, which was an AI agent that lets you interrogate some public data sets on ClickHouse.
Yeah. So
more broadly about how you're thinking about AI.
Yeah. So I mean, when you think about AI, it's a very overloaded term, right? I mean, sometimes you think about big AI companies, and most of them, if not all, are using ClickHouse, Anthropic, OpenAI, LangChain, DeepSeek, we talked about, weights and biases, so forth.
An insecure ClickHouse, just to reference, the DeepSeek is leaking all of our prompts on their ClickHouse.
Well, don't use DeepSeek, right? Only use those who are using ClickHouse Cloud. DeepSeek is not one of them. And then, like a few years ago, AI meant training models and running inferences, right? And, there's still a lot of customers who are using ClickHouse. We have RunReveal doing security analytics, and they actually built an MCP server on top of ClickHouse, and RAMP, an expense management system. They're doing vector search on ClickHouse, and it's built right into the database, so you don't have to copy data out into a separate vector database. You can do all of that there. But just looking at the audience here, how many of you guys have trained or run an inference on a model in the last 30 days, let's say? Raise your hand. Okay, so there's maybe 3 or 4 people, right? And then how many of you have used an AI agent, right? ChatGPT or anything else, right? Everybody. And even if you didn't raise your hand, I guarantee you, like if you used customer service app or anything else, I guarantee you used an agent. So I mentioned llm.clickhouse.com. That's a great example of what you can do with a semantic interface through an agent. If you have your phones or your laptops, you can open them up. Just go to llm.clickhouse.com. You don't need to have an account with us. You can go right now. And what we did is we preloaded a bunch of open source, publicly available databases like the GitHub repository history, or the New York taxi cab rides, or UK history.
Property, right? The property data set.
Yeah, the property data set. Like you can go to the prompt and say, show me top 10 most expensive cities in the UK using the colors of the British flag, right? Type it in, go ahead. And you'll see, and it's actually connected to Anthropic's Claude 3.5 Sonnet, I think, and it shows you all of the queries. So it translates, it understands. So the only context we're passing on to them is the schema, and it's smart enough to figure out which table you're referring to how to set up the query. It tries it. If it doesn't work, it adjusts it, tries something else. It's amazing. And or like go to GitHub and like how many pull requests for, I don't know, DuckDB, Pinot, Apache Pinot, and ClickHouse, and it tells you all of that stuff. And within ClickHouse, we've completely moved to agents. I have not looked at the BI dashboard probably in like 2 months, because we have an agent that, again, runs it, connects to it, and it's like once you try it, llm.clickhouse.com, you'll see it's amazing. And we do it for knowledge base, we do it for other things. And that's, I think that's really in front of us, the future, at least in the near term, is kind of building those agents, integrating them, putting them in front of databases, connecting them to various applications. And I think that's what's going to be driving a lot of the usage.
But I think it's important that these are the kinds of things that only work with fast, real-time databases. It's much harder if you're running these queries on a Athena.
If your query takes 15 minutes to come back, you will not be a very happy user of that agent.
Lose your patience. Okay, we have a few minutes. I'm going to open it up to anyone who's been holding a question that they'd like to ask of Yury, Kishore, and Jordan. I first just want to give a round of applause for you all three. And I think we do have a microphone here. Do we have a mobile mic? We don't? Am I the mobile mic? Okay, I'll repeat it. So any questions from the audience? Okay, go ahead. I'll try to repeat it back.
Yeah, so are you worried about having an open source software that then Amazon or Google or Microsoft just steals and distributes it to the gajillion people who are their customers as opposed to using your kind of cloud service?
Okay, we're going to have to direct that. I'll do the direction. So the question was, are you worried that Amazon, Microsoft, or Azure will just steal software? Certainly we saw that. That was a greater fear, I think, a few years ago when Elastic and Confluent changed their licenses. But I'm going to ask Jordan, because I think I have an answer already for ClickHouse. Jordan, how are you going to prevent Amazon from just starting, I don't know, Amazon Duck?
So a couple of things. One is the way we integrate with DuckDB is we're integrated inside DuckDB. So like you change your database name to start with MD:, and it loads our extension and starts talking to MotherDuck in the background. And so if Amazon is running a DuckDB server, like they won't have the ability to do that. There's a bunch of kind of mechanisms that we've built around DuckDB. DuckDB is an embedded database. It's not a data warehouse. All the sort of user management and sharing and scaling and all these things are things that like Amazon or Google would have to build around it. So like it's all code. Somebody could do it, but it's not like you just sort of take this service and run it in a Kubernetes cluster or container, and then you're done. Like so, we're not particularly worried about that. Partially because of the architecture, partially because just because DuckDB doesn't provide a lot of these features. And then finally, like the more people use DuckDB, the better it is for us. And like we would love to see the DuckDB community grow larger. Elastic, they certainly had hurt their business. The fact that Amazon, built a competing service, but they're doing okay.
I'm going to move to another question, but I think in general what we've observed is that the hyperscalers are now more friendly to some of these. They realize they make money, whether people use Amazon Elastic or they use Elastic Cloud. It's still compute that they can charge for. Okay, other questions? Go ahead. Is that Chipman? Yeah, I'll repeat it.
Question for you, more so, Michael. Given, and this is AI related, but just given that what you just described with LLM.ClickHouse.com, I'm very curious about this whole interfaces, what the future of interfaces, BI interfaces is, and I'd love to hear your perspective given your building there.
Well, it's a great question. I'm happy to answer it. I think the future of BI interfaces, I do think a lot of this is predicated on having real-time analytical databases, speed behind it. I believe certainly, while AI agents are a great way, natural language is a great way to prompt folks, I do still think there's something to be said for tactile interfaces. I often find that pointing and clicking can actually get you an insight that just sort of describing in natural language, what you're looking for is not as effective as dragging and zooming and drilling and pivoting. So I think, we're not going to say goodbye to all of the, visual interfaces that have been created. And, if that were the case, I think that company Narrative that just had, we'll just have a little pin that we talk to. It turns out people still like their phones. They still like to point at things and swipe. So I think the tactile interfaces have a place. So will the sort of natural language interfaces for analytics. And so I think both of these can kind of coexist. But thank you for that question. Other questions from the audience for Yury, Kishore, or, oh yeah, go ahead, please.
I actually also have an AI-related question. I'm curious, how do you see the development in terms of like database schemas and database APIs given LLM-specific, I would say, ways of handling data? Like, for example, I tried LLM.ClickHouse.com.
Just now? That was fast, amazing.
Yeah. And it queries a list of databases, a list of tables, etc., and it takes quite a long time. So probably it would be more efficient if it was preloaded with information about what data the specific ClickHouse database contains. So instead of just querying all the schemas, it can go directly towards querying this data. So do you see any specific tighter integrations between LLMs and databases in the future, which would allow for newer use cases?
Great, and if you can summarize the question, Yury, before you answer.
Yeah, so the question is, if you go to LLM, because we're only passing the schema as the context, it actually has to figure out which schema to use and what. So yeah, obviously you can pass a lot more stuff in the context. And if you use the Copilot in the ClickHouse console, for the SQL editor, we're actually passing more information. I mean, again, it's we're being very careful not to share customer information, but there's more information about the ClickHouse service that goes to, in that case, it goes to GPT-4. And there you see much faster. But it is really the judgment call of the developer of this agent of how to set it up and how much context to pass. In this case, we were actually quite surprised. We were expecting that in addition to the schema, we'll need to provide more stuff, but Claude just figured out how to interpret and how to adapt very well. It doesn't seem like it needs a lot of additional help. Yeah, it takes a little more time, but I actually like that it shows all the homework, it shows all the queries, and it's actually kind of a good way. If you're not a deep SQL expert, and I don't consider myself a deep SQL expert, I'm more of a distributed systems person, I think it's great. I'm actually using that to learn how it thinks and how to optimize things. But yeah, there are definitely ways how, by providing additional context, you can speed things up and provide additional shortcuts.
Okay. I'm going to take one more question. I see a hand raised over there. Okay, final question. You, sir, go ahead.
This one's mostly for Jordan about how most people's data sets are very small, or relatively small. I'm curious, one of the things that I've observed when talking to customers like that is they kind of don't want to admit that to themselves. They don't want to be the small data guy at a big data table. How are you guys running into that, and how do you handle it?
So the question was how do you handle people think that their data is bigger than it is, or people think that their data is going to be bigger than it actually is. So I mean, one of the ways is just around education. Like for example, the amount of hardware on a commodity, EC2 instance that's available in every region is not super expensive. Is 192 cores and 1.5 TB of RAM. That's roughly the equivalent of of the amount of hardware in a Snowflake 3XL. A Snowflake 3XL is $1 million a year. So if you're using less than a Snowflake 3XL, your workload will fit in one machine. So it's like, yes, okay, maybe you do have some big workloads, but like the other thing is, our tenancy model, we run a single DuckDB instance per end user. So you might have 1,000 users in your company. You each get the equivalent of a Snowflake 3XL. Again, that's a lot of hardware that we can throw at various problems. There is certainly like the mental block, and that's one of the reasons why we kind of poke light at where the boundary is between small data and big data. But I think that boundary is receding kind of every year as these machines get bigger and bigger, is sort of like the thing that used to need like really complicated distributed systems. Like, you can twice as much data, and then the next year is twice as much data, and then pretty soon, like, you may not need those complicated distributed systems.
Okay, I think we're gonna call it. Marianne, tell me, how long do we have for people to relax and hang out if they want to? Okay, so we've got about 45 minutes. If people want to come and ask these amazing founders, we'll give them a round of applause. Thanks for joining us, and enjoy the rest of the night.